All right. Basically, what we're talking about today is this. We've already talked about the square root of 49. Okay? The square root of 49 is 7. Now, we've also talked about that the only time you list a negative or a positive with it is when they've done that. So if they said this, then the answer would be that, -7. Okay? What we're going to talk about today is we're going to talk about those square roots that are not perfect squares. Okay? They want us to simplify the square root of a number, and it's not also by looking in the back of the book. Okay? We're not doing decimal equivalents. Okay? And so what they want is they want you to take 44 and they want you to come up with the square root of it. All right? Now, here's how we do that. There's two different ways that you can do that. This is fairly simple to see that 4 times 11 is equal to 44. Okay? And so our rules for radicals is this. That is an equivalent expression. Okay? The square root of 4 times 11 is the same thing as the square root of 4 times the square root of 11. Those are equivalent. They are the same. Now, when I break it down in that form, then I can take the square root of 4. What is the square root of 4? 2. Can I take the square root of 11? No. So that's your answer. 2 times the square root of 11. Okay? So what you're trying to do is you're trying to find a factor that does have a perfect square. Okay? In the number itself, for example, square root of 27. Okay? The square root of 27 obviously is not a perfect square. Okay? Now, like we said, we could estimate it, go to the back of the book, but we're not doing that. We're simplifying the radical to its simplest form without approximating. Okay? So as I look at 27, what is a factor of 27 that is a perfect square, Nick? 9. So I can break this down into the square root of 9 times 3. Okay, which once again is the same thing as the square root of 9 times the square root of 3. Square root of 9 is what? 3. So 3 times the square root of 3 is your answer. Now, obviously, these are fairly simplistic examples. Okay? Now, let's look at this one, square root of 48. Okay? The problem you have here is you might look at that and go, okay, well, 4. Well, yeah, 4 does. Okay, you can do 4. Problem is it won't be simplified. Okay, so let's look at doing 4. In other words, if I did 4, square root of 4 times the square root of 12. Square root of 4 is 2, so 2 times square root of 12. That's not right. Okay, because the square root of 12 can also be reduced down. Okay, so you've got to look for the highest factor as well that is a perfect square. Now, the other way that you can do it is you can simply do this. If we prime factor 48, okay, and we list everything in pairs. So this is the square root of 2 squared times 2 squared times 3. Now, for this one, realistically, you really don't have to do this, but I'm just showing you an example so when you get into larger numbers that you can't readily see, oh, okay, well, I need to do this. I need to do this perfect square. Or I need to do this perfect square. You can always work it this way, always works, every single time. Okay? And so what you have is the square root of 2 squared times the square root of 2 squared times the square root of 3. Well, 2 squared, and take the square root of it, is 2 times that, which is 2 times that. 2 times 2 is 4 times the square root of 3. Now, how do you get that in the original problem without doing the prime factorization? Well, you have to see that this is really square root of 16 times 3. Okay, what is the square root of 16? 4. Okay, so 4 times square root of 3. The other way that you can see it is right here. That's 2 times the square root of 4 times 3. Okay, which is 2 times square root of 4 times the square root of 3. Square root of 4 is 2, so that's 2 times square root of 3, which is 4 times square root of 3. Okay, so either way, any of those ways, you're going to come up with the correct answer. Okay, some people can see it real easily, some people can't. So the easier way to do it then is to always prime factor it. All right, let's look at this one. 1/2 times the square root of 112. Okay, well now obviously that's not the easiest one to do. Obviously. Okay, you may not be able to think of it real quickly. So, like I said, I would highly suggest you just prime factor it. Okay, and if you list it in their pairs, that gives me 1/2 times the square root of 2 squared times the square root of 2 squared times 7, not 4, 7. Because 4 would be just 2 squared again. Okay, and so now I have 1/2 times 2 times 2 times square root of 7. What's 1/2 times 2? 1. So that's 1 times 2 times square root of 7. 1 times 2? 2 times square root of 7. So what they were wanting you to see, the two factors they were wanting you to see was 16 and 7. That's what they were wanting you to see 112 as. Okay. Well, most of you would not see 16 and 7 right off the bat on that. I'd hedge a guess that most of you would not see that in a minute or two either. Okay, so instead of sitting there for a minute or two and go, okay, just prime factor it. Then list your prime numbers in pairs. If there's no pairs, then you can't do anything. Okay, try this one on your own. 1/3 times the square root of 54. Now that one you ought to be able to know the perfect square factor fairly easily. Now, the other thing is this. The number under the radical sign, under the square root sign, is not always going to be prime. Okay? I think a lot of these that we've done, the number under the square root sign was prime. That is not always the case, and it's not the case here. Okay? So it could be like it couldn't be a 4. It could be like not a lot of them actually starting off real small. It could be a 10. Okay? There's not a square root of 10. There's a square root of 12. Square root of 12 is 2 times square root of 3. Okay? So a lot of the smaller numbers will still have a square root that you can simplify. Like 14. There's not a square root of 14. Okay? So, you have an answer?
So for this, does it always have to be 2?
No. Whatever, it has to be prime. The number has to be prime. Got it yet?
No, I'm working on it.
Okay. Yeah. Yeah.
Oh, the second?
Yeah. Because you can't prime factor that. I mean, you can't take there's not a perfect square factor in that number. Because there are a pair of 2s. So that has to stay on the inside. It was right. There wasn't a pair of 2s. So that's what's left, but it's both of them are inside the square root sign. All right. Now, this is why it's always so important to know your factors. Okay? Most of you prime factored this. Okay, you don't have to. Okay, 9 times 6, 9's a perfect square, and 9 times 6 is a factor of 54. So that means I take the square root of 9 times the square root of 6 times 1/3. Well, 1/3 times square root of 9 is 3 times the square root of 6. Well, 6 is 2 times 3. You can't square that. So 1/3 times 3 is 1 times square root of 6, which is this square root of 6. If you prime factored it, which is fine, you can start with 2, you can start with 3. It just has to be prime. Okay? 2, 27, 3, 9, 3, 3. Okay, well, you can either do it here, so that's 2 times 3 squared times 3. Okay, well, that is that right there. So this is 3 times square root of 2 times square root of 3. And that's 3 times square root of 6. Because you can put those two things together. And then I take the 1/3 times that. Okay? Either way, you're going to get the same answer, providing you do the mathematics right. The easier way, I'm not going to lie to you, the easier way is to find that factor that's a perfect square. That's the easiest way. Less work. Okay? Can you always see it? Yeah, no. Sometimes you can, sometimes you can't. All right? Now, look at 21. 21 says the square root of 6 times the square root of 8. Okay? Well, don't get confused. That's just the square root of 48. That's all they're asking you. Okay? Well, we've already done this one, haven't we? We've done the square root of 48. I think, didn't we? Yeah. Okay. So, once again, you can prime factor it, or you can see that that breaks down into 16 times 3. Well, 16 is a perfect square. So the square root of 16 times square root of 3, and that's 4 times square root of 3. Now, can you do it up here? Yeah, you can do it up there, but it becomes harder. I mean, I can do this, square root of 2 times square root of 3 times the square root of 4 times square root of 2. Okay? 4 times 2 is what? 8, which represents the square root of 8. 2 times 3 is what? 6, which represents the square root of 6. Okay? Well, then I can break that down into square root of 2 times square root of 3 times 2 times square root of 2. Well, these two go together. They're the same thing, which that is the square root of 4 times the square root of 3 times 2. Square root of 4 is what? Square root of 4, is 2 times square root of 3 times 2. Those two go together, 4 times square root of 3. That's a lot more work than if you see it like we did here. Multiply those two together, 48, and then take the square root of 48 and see that it's 16 times 3. Okay, now, remember, if it's on the outside of the radical sign, you cannot multiply it. In other words, I can't take 2 times the square root of 3 and say it's square root of 6. Can't do that. Inside of the radical sign, you can multiply things together. Outside, you can't. That moves us to the next part. Ah, yes. Let's see. I love it when they probably don't give you an example of these, do they? Let's see. Well, there's one sort of. No, that's not one. That's not one. That's not one. Yeah, it figures. They don't ever, that's what I love about these books. They don't ever give you examples that are like the harder ones. All right. 2 times the square root of 10 over 2. Let's look at what we have to do with the 10 over 2 first. Let's look at that. That is the same thing as it's that, or it's what you just said, square root of 5. Okay, in the future, it won't be that easy. In the future, you'll have something like 10 over 3. Okay, and there's a rule for it, and it's really not that hard. It's fairly simplistic, but I don't think, that's what I'm trying to look at, I don't think they give you any of those. They don't, well, but that 13 over 9, you can take the square root of 9. So it's a perfect square, so you can take the square root. The rule is this: if you had, and I believe they present it to us in another section, but if you had the square root of 10 over 3, let's say it was just that. Okay, the way we would do that is this. Now, I can't have a square root sign or a radical sign on the bottom of a fraction. That's not simplified if you do. And so what you do is you take and multiply top and bottom by that. That's what you do. And this right here becomes 3. Because if I take the square root of 3 times the square root of 3, that's the square root of 9, right? Well, it doesn't matter if it's on the top of a fraction or the bottom of a fraction. It's still 9, which take the square root of 9, which is 3. That's how you get that 3. And then on top, you have the square root of 30. Because what is 3 times 10? 30. Okay? And that would be that fraction simplified. We're not going to have any of those. Okay? There'll be a way for you to reduce it, either like we just did here, dividing 2 into 10, okay, or like we're going to show you here in a second. Okay? So this, we said here that this is 2 times square root of 5. The reason you do that is just dividing 2 into 10, goes 5 times, leaves me with square root of 5. All right? So, not that difficult, just a little confusing. All right, let's look at 28. 28 says 8 times the square root of 13 over 9, right? Okay, still the same thing. Still not any harder. This is 8 times the square root of 13 over the square root of 9. Okay. What is the square root of 9? 3. So this is 8 times the square root of 13 over 3. Now, is the 8 go on top of the fraction or the bottom of the fraction? Top, because it's a whole number. So that's just 8 times the square root of 13 over 3. And that's it. Because remember, this is the same thing as 8 over 1. A whole number expressed as a fraction. So that's your answer. All right, do number 31 on your own. Very similar to what we just did. I believe it's 3 times the square root of 3 over 16. Yeah. Yep. Mhm. 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 All right, so that one is really this. And if it's easier for you to understand it this way, then write it that way. Okay? Whatever is easiest for you, as long as it's an equivalent. Okay? Don't be making up your own expressions. Well, that's easier, so I'm just going to write it that way. Well, it's not an equivalent expression. Okay? So, what we can do here is 3 over 1 times, there's not a square root of 3. There is a square root of 16, which is 4. Okay, then you just take 3 times square root of 3 over 4. And that's your answer. Okay, don't make it harder than it is. So if we have this, square root of 27 over 36. So that's the square root of 27 over the square root of 36. Well, the square root of 36 is easy. That's what? 6. Okay, square root of 27, 9 and 3. So that's the square root of 9 times the square root of 3. So that's 3 times square root of 3 over 6, which is square root of 3 over 2. Right there. This is the same thing as 3 over 6 times the square root of 3 over 1. Well, since today's lesson is simplifying radicals, simplifying radicals, that is not simplified. So 3 over 6 is 1 over 2 times the square root of 3 over 1. And so the square root of 3 over 2 is in simple form, or simplest form, not in simplistic form. Now, square root of 120 over the square root of 4. Now, 2 ways you can do this problem. The easier way is to do this. Okay. Now, 4 goes into 120 30 times. So you have the square root of 30 over 1. Well, what is the square root of 1? 1. So realistically, that's just the square root of 30. Now, you can divide it up and say, okay, square root of 4 is 2. Now I got to figure out what the square root of 120 is. Okay, square root of 120 is going to be square root of 4 times 30. Okay, square root of 4 times 30 is 2 times square root of 30 over 2, which is, those cancel out. Okay, do it the other way. This was obviously the easier way. Okay, if you can divide that into that, then go ahead and divide it. Okay. Now, I want you to try this one on your own. One half times the square root of 32 times the square root of 2. All right. What do we get? 4. That is correct. Now, once again, they make this harder than it really is. Okay, just simply take and multiply those two together. That gives me 1/2 times the square root of 64. Square root of 64 is a perfect square. Okay, that's 8. 1/2 times 8. 4. Okay, y'all went the long way, right? Yeah. Don't go the long way. You take probably, you did you did even that though, 16 times 2. Square root of 16 times 2 is 4 times square root of 2 times the square root of 2, which is the square root of 4, which is 2. So we have 1/2 times that 4 times that 2. Okay, a lot easier the way I did it. Okay, you got to look at things. You got to see it in your head. Y'all always want to do stuff in your head. Okay, see things in your head and find out the better way to do it. Now, 46. 46 says the square root of 7 times the square root of 18 over the square root of 2. Okay, don't make this harder than it is. Very simple. That right there. 2 goes into 18 how many times? 9. So that's the square root of 9, which is 3. I'm done. This is 3. Okay? This right here is 3. So that's 18 over 2, which is 9. Square root of 9 is 3. Square root of 7 doesn't have anything. And so I just multiply it together. All right? Don't make it harder than it really is. Your homework. Yeah, you're going to love it.
All of it? These are really short though. Wait, what?
10 through 56.
We have to study our hair and over.
Yeah.
Oh yeah, that's
You're only going to have two homework assignments this week, so because you won't be in this class on Wednesday and Friday. Half of you, they divided it up like L through Z and K through A or A through K by your last name, and I have half of you, and Miss Shorter has the other half.
Wait, which one has the L through Z?
I think I have the lower half.
No.
I think. Let's see. Touch me again, I'm going to deck you.